All right. Hi, YouTube. Said, Taha, Srikar. Hi, guys. We'll start with the problem A, obviously. Atcoder jumper. What is this? Oh, it's a screenshot. Okay, I thought it's some kind of new feature. There are n pages. Basically, the statement starts here. Didn't catch your stream for a while. That's because I didn't stream. For like 1 week, I was in my family town, just resting, spending time with my family. And only now I'm back to streaming. Okay, let's start reading from here. For each I, add links from I to AI and BI. You must be able to jump from any page to any other page by clicking at most 10 links. So kind of a logarithm. Square root will not work, so it must be logarithmic. I wanted to say that we build a segment tree, but it will be 2 times logarithm. Maybe some kind of improved segment tree? Here's a link if you want. Or maybe wait. Custom commands. The link command isn't set up yet. It will be. Oh, I have those bars from recording something. Now it's better. Link. All right, now if you type link, it will work. Cool. My first fault is that we make some kind of directed segment tree, where from every parent you will have edges down to children, and then from leaves of this binary segment tree, no, it's just binary tree, you will get edges down up to the root, but then the maximal path will have length twice logarithm. Okay, path from 2 to some kind of leaf on the right. I will make a drawing. But before that, some fast pings on Twitter and Discord. Right. Yeah, drawing. I was looking into changing my drawing software recently. I might just need a new drawing tablet. For a moment, let's assume this. Okay, let's make one more row. 9, 10, 11, 12, 13, 14, and 15. And I assume that leaves have edges up to the root. Maybe, well, they can have two edges. But if I want to start from here and I want to end there, that will take me 1, 2, 3, 4, 5, 6 steps. And in general, that's twice the logarithm. Please enable chat in YouTube. You can just use chat here. This type of stream where I solve very hard problems, it doesn't rely heavily on everything being interactive. So if you want to use chat, you can just open Twitch chat on the other tab. What I will do next time is, like here, maybe below my face, I will make messages to pop up, just to make it visible for a few seconds, like everybody else does, basically. Like Neil or Eknerwala, they all have chat displayed on the screen. Maybe that's just better. It's inconvenient for me to handle chats from both websites. Can I, if I just smartly choose edges from those, maybe from every leaf, one edge will be to vertex 1 and one to something completely else. Like to the, let's say from 8 to 12, from 9 to 13, basically to a corresponding leaf in the other subtree. Doesn't help if I go there. Maybe every second vertex will have such an edge, and so then from 8 to 12, from 10 to 14, then in some other color, from 9 to 6, from 11 to 3, something like that. Then from 2, I can get down to 11, then from 11 to jump directly to 3. Oh, but that doesn't help. I still have logarithm to cover here, logarithm to cover there. That is not enough. Kushiksa, who you have a difficult name to pronounce. Today I'm just solving hard problems from Atcoder, like the title suggests. Can I do something different than this kind of binary tree thing? Once again, the statement is this. You're given a single integer n, and from every I, is there a drawing? No. You need to create a graph with vertices 1 through n. From every vertex, you need to put 2 directed edges, so that from every vertex to every other vertex, you could get in 10 jumps, 10 being logarithm of n. This means that there just can't be any repetitions. That's an interesting thought. Well, there can be some. After exactly 10 steps, you can be in 2 to 10 different vertices. You have some vertex, then you can get to 2 different vertices, then 4, and so on. After 10 steps, that's 2 to 10th power, so 1024. In total, if nothing is repeated, you can visit 2000 vertices. This kind of tree, it saves us one step. I mean, from vertex 1, we can get here to everything else in 9 steps, at most 9 steps. Maybe then, sometimes instead of having 2 children, we should remove one edge. Imagine this kind of tree, where 1 has children 2 and 3, but then 2 has only one child, say 4. Here 5 and 6, and so on. Not every vertex has 2 children. 7, 8, then 9, 10, 11. It's not really binary logarithm. Say maybe log of base 2.5, and maybe that's good enough, or 2.2. Does that make sense? What I want to say 1.8. Yeah. And when one edge is only to a child, the other can do something else, like go back to the root or to a random vertex. I can try a completely random graph, but I don't think that's good enough. Though once I construct that graph, I can hard code it. Yep, the limits are small enough that I can create this graph on my own and then just paste it in the code. Do I like Catis for competitive coding? I don't use Catis, so I don't know. Catis, I think, holds some past ICPC finals. I would use it for that. Can you choose mean of right and left? I don't know what you mean, but the values you put here don't matter. If the tree looks like this, that's not good, because you cannot get from this vertex to this one fast enough. Unless maybe you smartly choose edges to which you can get from leaves. How much should I spend on a problem before looking at editorials as a blue coder? As long as you have new ideas. N is up to 1000. And you need to get anywhere in at most 10 steps. I need to learn how to use, I need to get used to use this written text instead. But the annoying thing is in OneNote is that you cannot use the default color. You cannot change the default color. Okay. But this will obviously be nicer. Those are the constraints. from this vertex, you can get to any of those leaves. They should allow you to kind of immediately jump to anywhere here. What if they allow me to jump to anywhere here? Don't make an edge from 8 to 12. It might be a good idea. I will copy some kind of binary tree drawing. Does it work? Yes, it does. From 16, let's make an edge. Wait. I want to have edges from those to everything here. There are 8 vertices here and 7 there, so that's possible. But how to decide what goes where? If I start here, from there I can get to any leaf of my choice below. And from there I need to jump somewhere here. And in at most one extra step. That's 9, that's 8, 9, 10. Yeah, in one step I need to get everywhere. So I think that there must be edges to everywhere here, and then like every second layer would be enough. If I start from there, then I can have one extra step. Let's try this. From 16 to 3. From 20 to 3 as well, or not? Do we need repetitions? I almost cannot have repetitions. I need to be able to get to everywhere here. So maybe every second will be for that. 12, 13, 14, and 15. Then in any order 3, 6, and 7. Oh, and an edge up to 1 would also be nice. From each of those leaves, there is an edge to vertex 1, the root, and also an edge to from 16 to 12, from 17 to 3, and so on. Would that be good? And from here, I don't even use the second edge. From there, can I get to anywhere? Well, I can choose some leaf and then I will be able to jump to anywhere here in one extra jump, and then maybe like from 12 to a leaf. Also to 1, so yeah, I'm good. What about starting from 4 or starting from 5? I have here edges to 7, 14, and 15. That seems very dangerous. What if I want to get there? Here I would need to basically go here, then jump up to 1, then go there. That's bad. Should 3 be repeated? For node x, you can choose x plus 1 over 2 and x plus n over 2. That sounds very, I don't know, arbitrary. I can investigate your idea later. I first want to try mine. So to do for later, to check this idea, from x, go to x plus 1 over 2 and x plus n over 2. I don't know. Should I go for code versus contests? As I know, blah, blah, blah. Doesn't matter what you know, you can try. Then you will see if it's too hard. What if you make two binary trees and join them at the leaves? I don't see what you mean. Like if you have edges from root down to children and eventual to leaves, then I don't see how you want to join them at leaves. In your current idea, one of the links always gonna be the root? Yes. From leaf, I want to say that going to the root is allowed and going to some other vertex. I also heard that, I don't know if in which day, first or second day, but in one of them I heard that even the first problem was very hard and it took an hour to solve. I don't know if it's this one. But at this moment in contest I would already look at the standings, so let's do that. I want to see how quickly best people solve it. I will kind of not look at the right part of the screen. You can do it too. Oh, 2 minutes. 3 minutes. Actually, those times are quite strange. I see some like 25 minutes. The best time is very good. Maybe just it's because this problem isn't that complicated. The statement is quite simple, and then some people just know a problem because they already encountered the same one. Did you get this idea because you saw, yeah, 10 is logarithm of 1000, so obviously I'm investigating idea of a segment tree, like a binary tree. By node number, we can know level of the node. That's correct. I mean, I don't here worry about implementation of this. Whatever I can come up with, I will be able to implement. It's just that I need a good enough idea. Hi, Summer. Thank you. Yep. Hope you had, if you already had, a good stream. In Eknewal's stream, he said he had seen it before. Okay, then maybe. When you come up with a problem as author, then the simpler the statement is, the more likely it is that this problem exists out there and some participants will know it. And know, even if you have like 10 testers, still the number of participants is so big, and it's then more likely that one of them already saw it in maybe a local competition. From here, starting from a leaf, it is fine to just go to 1 and say that everywhere everything can be achieved. Starting from 11, it's bad to jump here because maybe let's draw a bigger, let's think about a bigger binary tree with layers. From something here, it's okay to just go to the root and then go down to anything. That's fine. For the second last layer, if you go up to the root, you will not be able to reach a leaf. That's too many steps. So from one of your children, maybe let's say this one, it would be nice to be able to jump here. This is still problem A. But this would mean that every second leaf points to vertex 3. Or vertex 2? Oh yeah, actually the same happens for being able to get there. So you would need to point to 3, and you would need to point to 2. And then that's bad because we used all the leaves. Or is it? When you want 1000 vertices, then in the last layer there are 512 of them. That's 2 to 9th power. The first layer is 1, so that's 2 to 0th power. So there are 10 layers numbered from 0 to 9. The number of steps from the root to the last layer is 9. So from here, you can jump 1 and then 9 steps, that's fine. From there, it's impossible. I see. In my setting, indeed, I would need those red edges to 2 and to 3. So that it would be able to get to anywhere from there, from parent of leaves. And what now? I cannot say that all the leaves, they just point to 2 and 3. If we know that the level of node, we can jump in that row. I don't know what you mean. Yes, for every node, I can know its level, and what then? I'm solving a hard competitive programming problem from Atcoder. If you choose log of n minus 1 leaves on the left half and link them to each level on the right half and vice versa. Well, how does that help me? Let's say that this is the starting node. Then it can only access those 2 vertices in one step. Okay? There is some edge from this one and some from this one. And I showed here that those edges, they need to be to 2 and 3, unless I'm off by 1. Can't I do something which teaches us a bit too? You can, obviously some people will learn from this. This is a hard problem, and you know, some people are on this level. So yeah, you cannot guarantee that, answering to Sahil Rocks, you cannot guarantee that from those 2 leaves, you can get directly to every level on the other, let's say, subtree, because you have just 2 edges to use. If you want to get from this starting node to, let's say, this final node, then you need to directly jump from one of your children to this guy, 3, or something below, but it would need to be on the path to this particular leaf. Only 3 makes sense. Otherwise, if you choose this red edge to this vertex, then you will not be able to efficiently move to something here in the subtree of left child of the right child of the root. All the problems will be hard in this stream. Yes, that's correct. I don't know if I will participate in Forces Goodbye. Maybe. I'm far behind with all my work, all the responsibilities because of Christmas. Maybe it should be sorry, not segment. Maybe it should be binary tree directed up. Like that. Then how to get from somewhere down? I can say that every edge is double-edged, like double directed. On one hand, this seems so much worse, because you can get only to handful of vertices. On the other, we only used one edge from every vertex. How should we use the other one? In particular, from the root, there should be, what 2 edges there should be? You can put edges to a neighbor, the other child of the same parent, and you cannot put edges down as well, like this, because so you cannot make all edges double-edged, because then there would be 3 edges coming from the same vertex. But you could make this. Every out degree would be 2. From the root, I would just put edges to 2 leaves, like the leftmost and rightmost leaf. And then going down is very easy, and from there to get here you would need to travel like that and like this. From here to travel there. How to get from here to there? You need to go all the way up. Yeah, then like this, then that, and that's over twice. That's over logarithm of n. Some correction, node x2, blah blah. Magdot, I don't know if you know the solution or not, but you're just saying kind of random formula. I don't know if it works, but during a contest, for sure, I wouldn't suddenly try this formula. Maybe it's correct, indeed. I can check if it's correct by just drawing what you told me, but I'm more simulating here what I would think of, basically without any help, without any editorial. And if you give me an idea like, what's about investigating square root decomposition, then sure, I can try that. But here you're giving me a random formula that either works or not. And I don't like the fact that I don't like the idea of me just taking this formula and seeing, oh, it works, even if it does. What makes sense to me is trying some binary tree with extra edges. So far it doesn't work. International tournaments, they put hard questions like this. Yes, they do. I'm solving a problem for half an hour. If every problem in a big international tournament was solvable in 10 minutes, then the whole problem set of 6 problems would take everybody just 1 hour. Well, it should be a challenge. Good. This doesn't work for now. Let's try something else. Let's try. Maybe I will need to assume that n is prime. We'll see about that. But let's try to do move from x to x plus 1 and from x to x plus something, x plus n over 2. This will be basically, this might be very similar to idea by Magdot, but we can imagine some kind of field modulo n, and there we can move in some way. This idea is very stupid. This just allows us to move by plus 1 or by plus some other value. And here to get from x to x plus 20, for n being 1000, you would need 20 steps. So this cannot be a constant. If it's square root, then we can get anywhere in like twice square root of n steps. $11, $12. Imagine that those are edges by default. You need to put some extra edges, but you want to make it possible to get from anywhere to anywhere in log of n steps. What about putting random edges? Did you try AlgoExpert very hard problems? Yes, I did. Nothing there, when I tried, there were like 2 very hard problems. Nothing there was really interesting. But you know, coding interviews and competitive programming is just very different. Some coding interview problems are interesting. But there it was like airport connection problem was just, spoiler alert, about strongly connected components or something like that. So it was extremely standard. You wouldn't see that in competitive programming contest because, well, it's just a well-known algorithm, that's it. I don't remember the other very hard problem. I like coding interview problems about using small memory because that's unusual. So achieving like constant space complexity. What about going x to twice x because we are looking for log time? Well, I tried that for a long time here in my binary tree. Just from x to 2x, it would be to go to left child. (2x) modulo n. I would need to remove one of those. If I do this, so increase by 1 or multiply by 2. I don't know how this works. I would try to solve for small n by hand. We can try to come up with something that will work for 8 in 4 steps, but for small n, the fact that we can do 1 extra step over log of n, it can mean a lot. the when I was trying to find a pattern like here, I basically thought about a small example. I wanted to solve n equal to 15 in like 4 or 5 steps. If I solve this with those yellow edges and red edges, then I would apply it to the bigger example. For this whole time, I'm thinking about a smaller example, kind of. Not divide into half, it divide into log of n, but you cannot have log of n edges. Can you share secrets for reducing time complexity? Yes, this whole stream is about that. My whole channel is about that. If you know algorithm, you need to apply algorithms and improve them. From x to 2x and 2x plus 1. Yeah. In tensor, you're just suggesting some small variations of segment tree, of binary tree. Sorry, I keep saying segment tree. And the issue is with this is that you can go down, but you cannot go up conveniently. You need to do the whole full circle. I'm not sure what happens with... I tried to decide what to exactly do with edges from leaves. Can we do something like a skip list? Skip list has a lot of edges, right? Or not? Skip list was something like from 1 we can jump to 2, from 2 we can jump to 4, from 3 to 4, from 4 to 8. Was it like that? If from 4 we can also jump to 6, then that's log of n edges from every vertex. But I like the idea about the skip list. Let me remember what that really is. I remember that in my first year of university, you need to implement skip list. Yeah, there are a lot of edges in the skip list from a single vertex, so that's a bad idea. I need 2 edges from every vertex. X to x over 2 and n minus x over 2, like a binary search? N minus x over 2 isn't a binary search. What is that? Oh, well, it kind of is. Sahilrock's suggestion seems to be related to thinking about it as a field or a circle. From 4, we can go to half of 4, or we can go to what? I see what n plus x over 2 would do, because it would go there, or from... I don't know what to do with odd numbers right now, but from 6, let's say, go to 3, or go here to a middle between u and 0. Did I do something wrong? No. I don't see why this would work. X to x plus 1 over 2 or n plus 1 plus x over 2. Yes, I'm kind of doing this plus minus 1. Damn it, stupid OneNote. No. Wait, okay. From x, I'm doing now, I'm considering this from x to x over 2, assuming that things are numbered from 0. From x to x plus n over 2. It would look like that. From a vertex, you go to half, or you go to middle between u and n, or 0. From 10, you would get to 11. Why is it now fast to go between any two numbers? From 1, you can get to anywhere because you multiply by... no. Yes. Well, you have unique multiplication by 2. Do you? What is this? Plus n over 2. You divide by 2 your distance to 0 or your distance to n. I don't think you can efficiently get from there to everything here. Because you can get much closer with this operation, but you would need to keep doing this for like the whole time. Maybe once you can do that. And by deciding when to do it, you can make some choice indeed. But you will not be able to go to all the numbers, let's say, in the left half of the drawing. I don't think this works. Does it? Explore binary representation of x. Binary tree kind of does it. From x to x plus log of n. This way you will need a lot of steps to get from 0 to n. Like n over log. And this. If you only jump by plus 10, you will need 100 steps to get from x to much bigger value. Solving every day but no improvement in rating? Are you solving problems for like 5 years already? You should solve problems, that's my advice. X to x over 2 and x plus n over 2. I don't see why it would work. Yeah, okay. So this or that. Divide x or add n over 2. This is commented out. We don't consider that, just first line and the third one. Why is it good? Seems really similar to level ancestor problem. I don't know what that is. 1 year and you're stuck at 1200. I will tell you something related regarding being stuck at some level. If you look at my rating, I was stuck at level of, let's say, 2600 or 2700 for 1 to 2.5 years. Yeah, 2.5. From this moment to there, What we're seeing now. I was stuck like that for more than 2 years. So then, if I was also stuck for more than 1 year, why are you asking me for advice? Being stuck for a few years with your rating is fine, as long as you're learning new stuff. Rating isn't something, deterministic. Your contest performance is kind of random. You can have a worse or better day. Just have a goal of solving 1,000 hard problems, then you will be better for sure. I don't know if I will participate in Code versus Goodbye. Maybe. All right, at this point, I give up with A. I want to move on to other problems. And I'm sure that already in the chat the correct formula appeared, but let me see the correct formula, and then I will try to analyze it. What? From x, add two links to 2x and 2x plus 1, modulo n. Hmm. Hmm. What? So this was the correct drawing. We've just, let's say 0, from 0 to 1, from 1 to 2 and 3. Yeah, everything here is all right. From 8, n is 16. So from 8 to 1, and from 9, no, from from 9 to 3 and 4. All right. I had a bad assumption that from every leaf there must be a directed edge to the root. Which is not the case. Oh, sorry, from 8 to 0 and 1. It should be. Like that. Then from 10 to 4, 5, from 11 to 6, 7, and so on. My first idea would work if I didn't assume that we need an edge directly to the root. I see the proof. The proof is extremely easy and nice. This one. You can get to interval of values, modulo n. It took me 50 minutes. It took me 50 minutes to give up. Do you have a friend which is not from computer science but still has good coding skill? Yes, obviously. Not every programmer is after computer science. A lot of them did math. That was... So this is why Atcoder problems are very hard. Even if solution is so easy, it's that hard to come up with it. What do I need to print? The edges? Every I print twice I modulo n and twice I plus 1 modulo n. But everything is actually numbered from 1 to n. So like that. Yes, I failed A. I spent 50 minutes on A and then gave up. But if you look at standings, some other people didn't solve A in minutes. I'm looking at some examples of bad times by strong people. I think this is a good example. 39 minutes to solve A, and then every next submission is after like 20 minutes or more. Plus, I have an excuse of commentating and explaining my thoughts, and that obviously slows me down. During a contest, maybe I would give up after half an hour instead of 50 minutes. All right, second problem. Nope. I'm updating the link. All right, the link command should work. Can you talk about the proof? I mean, there is nothing much to talk about. If you start with x and you in one step can get twice x or 2x plus 1, then from 2x you can get 4x or 4x plus 1. From twice x plus 1 you can get 4x plus 2 or 4x plus 3. So always you can get an interval. You always, after say 10 steps, every time you doubled the previous value, so you always have 1024 times x plus some constant depending on when you did plus 1. Basically, you can look at, I don't know, a binary tree. If you have a huge binary tree with like billions of vertices, and somewhere in this huge binary tree there is x, well, its children are 2x and 2x plus 1. Here there are 4x plus 4x, 4x plus 1, 4x plus 2, and so on. Generally, after any number of steps, you have some interval of vertices. This will be, say, 1024 times x, then it will be this plus 1, and so on. Interval of 1024 consecutive values. Like this is interval of 4 consecutive values. But all of that is taken modulo n, but it's still some consecutive values modulo n. If you take any 1024 consecutive values, say 5500, 5501, 5502, and so on, if you take this modulo 1000, and there are that many of them, then you will get every remainder modulo 1000. Would you consider doing some Olympiad hard problem streams sometimes? I would, but I like Atcoder problems. They are very unique. So I'm doing those mainly, and I don't want to do several streams a week with non-easy problems. In particular because I don't get many views from those. I should solve easy problems if I want to get views. All right. Problem B. As always in Atcoder. Actually, they use too many of those problems. You can perform some kind of operations, analyze what happens. Choose 3 consecutive empty cells and point a coin in each of those. Or 3 consecutive cells with coins, remove coins. You have a binary string. You can change 3 consecutive equal bits, like same bits, into the other type. All right. I like short statements. We start from what? Oh, all cells are empty. We start from empty binary string, with zeros. Like this. We can take 3 consecutive equal bits and change them to the other type. Like this. Maybe then I change that. Maybe then I change this. And I'm given information for every position. What's the score of that? If this is a 1. If this is 1, I get +5 to the score. If this is 1, I get -7 to the score, and so on. I need to maximize my final score. All right. One idea is to implement a brute force and see what kind of final binary strings I can get and try to understand some properties of them. If I was allowed to flip any 3 consecutive bits, then the order of operations wouldn't matter and I would have that many possibilities, because that's the number of positions from which I can start. Like this, that, and that. There are n-2 possibilities to choose 3 consecutive bits. In particular, that's the number of possible first operations. And then that would be very easy DP from left to right, remembering state of two most recent bits. But I doubt that the order of operations doesn't matter. N is small, so maybe we will do some DP on intervals. Like what's the best possibility to do something with this interval, with this final state of 2 first and 2 last bits. Then we will in some way merge those intervals. Can it ever happen that I twice use 3 consecutive bits? Can it happen that I change those from zeros to ones, then I do something, and I change them from ones to zeros? I don't think that's possible. I wonder if it would be if this brute force would be correct to just try n-2 factorial orders of applying those operations. How many flips are allowed? As many as you want, indeed. How many states can we reach? For sure, it's exponential number of them. It's limited, I think it's limited by this. Well, yeah, for sure it's limited by this. Cannot be more, because if for every position of 3 consecutive bits you are told whether you flipped those odd number of times, you will know the look of final string. If this is a correct brute force, every 3 consecutive bits are taken and flipped only once, does it mean something for me? I do something with those 3, then with those 3, then I flip back those. So what? Maybe I also took this, flipped those, and now some interval here I can flip back. This would give me 1 1 0 0 1 1 1 0 1. Is that for sure possible? I got it by doing first with 3 operations making ones, then flip this and that, and then flipping this will indeed give me the binary string from above. Can I get this string in any other way? In total, I flipped something starting from here, from there, there. Oh, and also ends are important. So I did this pair, those 3 consecutive guys. I did this, that. Oh, but also those 3 were done. Those 3. Is that everything? Nope, I also touched those. I'm out of colors. All right. So if at some place there is odd number of dots, it means that the different bit, I will get different bit at the end. Every colored pair like this one, it means that at one point I modified those 3 consecutive bits. I don't know the order of that. From where the colored dots are, I can retrieve the final binary string. If there are 2, then they cancel out. I could maybe treat this in total as something longer, like from here to there, of length 6. Do you work out your muscles? Can you work out anything else? Not a lot. Advice to stop procrastinating? I don't know. I'm not a psychologist, but I'm sure Google uses that. You can watch some YouTube videos about stopping procrastinating. You can watch those videos for hours. You just remember that this is different pair from those blue because I was out of colors. I always feel so stupid while solving Atcoder problems. Will it ever happen that I will modify the same place 3 times? Maybe not. Maybe it's important that we do 3 consecutive bits instead of just k or 10. Maybe I can say some kind of lemma where right? If it's true that I will not flip the same interval twice, then one position can be at most 3 different intervals. The most complicated process there might be is from 0 to 1, from 1 to 0, and from 0 back to 1. And this process happened here. Right? This one was modified 3 times. It's in yellow pair, green pair, red pair. Yeah, 3 times. Let's hope that that's the most complicated situation there can be. Once, then zeros, then ones inside. Initially I have zeros all the way. I can change some intervals with lengths being multiples of 3 into ones. These are all ones, these are all ones. Then I can make some holes. I don't think the hole can reach this. Holes will look like that. Those are again zeros. And I can make new holes in that with ones. And we hope that nothing more complicated is possible. Maybe it will be dp of from left to right to indices, and here it will be like 3 possible stages. This is stage 0, stage 1, stage 2, and stage 3. Like for every interval from L to R, maybe I can say if this interval is full of zeros, and now I can change some intervals into ones, but I cannot do anything more, then what's the score? And that will be called dplr0 or something, or 2. Then to do this in optimal manner, I will use shorter intervals of that previous type. Yeah, and up to 500 really suggests that it's some kind of interval dp. And I will have here cubic complexity. Let's change how fast my screen locks up. Screen, lock screen? No, that's not what I wanted. Power settings, is that it? No. Blank screen, yeah, 15 minutes will be better. 12. This is correct based on some lemmas that I didn't prove. They seem reasonable. Yes, I'm using VirtualBox with Linux. What you see now is Windows. I draw in Windows. What about this lowest level? By default, everything is 0 and you can change things into ones. So let's say that this red thing, it is some kind of dp of L, R, and of type 0, level 0. Maybe 0 should go first for cache reasons. Yeah, it will be better. It will be more cache efficient. dp0 of LR. This is defined only for intervals with length being multiple of 3. And this value, this is of type int. This value is just the sum of values from the inputs. Then when I try to compute this dp1, this thing, I will by default take nothing, but I can take some interval with length being multiple of 3. I can change to this. This will be dp of 1. This will be dp of 2. And finally, dp of 3 will be the answer. So I need 4. Int. And actually that dimension goes first. Maybe based on parity of the dimension, whether it's 0 of the first dimension, whether it's 0 or 1, whether it's even or odd, I will take values like the part here that I do not take, that the definition of that changes. All right, I think I understand it enough to start implementing. Right. I need to read the input, that's for sure. I will start with the first layer, the red one. Two-dimensional array n by n, by default filled with minus infinities. This is problem B. 3 coins. No. For every L, I take the sum of values from the input. But this needs to be multiple of 3. Or is it enough that I say I only do it for size 3? I can pretend that those red intervals, they just touch each other. So not length being multiple of 3 here, it's just length exactly 3 in that first layer. Yeah, sounds good. dp of L up to L plus 2 is a of L plus 1 and L plus 2. If I need interval of length 6, my DP will just consider taking 3 and 3. And now repeat something 3 times when going to every next layer. Let's call it turn, or like phase, stage. I will create a new DP. Eventually this will happen, and I need to print everything from 0 to n minus 1. Yeah. The actual logic. So for every interval, u must be of length multiple of 3, unless it's the last stage. The last stage just contains everything, because by default everything is 0. There are 1, 2, 3 stages. Here by default everything is 0, but you take values from those. So dp of this is right. Either we have the same score with this shorter by 1 interval or shorter by 3, or we really need all those values and there will be some red at the very beginning. Let's analyze this again. If I want to compute score for this, let's say that length is multiple of 3. It will be the same as score for that part, because that I already know how to optimally make holes here. Let's say this, in this part. Maybe we should pretend that this is allowed for any length. I want to say that score for this white part is the same as score for this blue part, unless one red hole goes there. So dp of LR is the same of dp of L up to R minus 1. Or exactly this case. Either this, dp of L, R plus 3. Plus previous dp, new dp. New dp represents new stage. R minus 3 plus the previous dp, the red hole, from R minus 2 to R. Oh yeah, like that. Assuming that L and R are small enough. Because we use here smaller r, we use here greater L. L must go from big values. Oh, it doesn't matter because that's dp, so never mind. I will need some ifs here because that might be out of bounds. And additionally, every second stage I have some values. Here, nothing is taken. Red holes, they have values. Everything not taken doesn't have values. That's the first stage. In the second stage, everything that is not a hole, it has a value of AI. Turn modulo 2. If yes, then nothing. It's number stages from 0 to 3. A of R, else 0. Let's just call it second stage. And now, if this is a second stage, then I need to add your value. What happens here? New dp of this plus that. That is not modified. But all of that I do, I think, only if interval is long enough. Intervals of length at least 3, then do this. Otherwise, do that. If second, then the sum of values, otherwise 0. So this is just sum of values from L to R. Like here. I hope it works, but I actually doubt it. It would be too easy. Right, out of bounds, -1. Where do I access -1? Here? There? Yes, here. If L is 0 and R is 2, then this is satisfied. But this is interval from L to R -1. That's bad. I should treat this as 0. If R is equal L plus 2, then this is 0. for L equal, yeah, this should be fine. 0, that's not good. For now, my program always prints 0, but for the last sample test, it will be correct. All right, 1 out of 3 passed. Just like a program that just prints 0. Why Richter does not use Vim? Why should I use Vim? If there are multiple choices of something like coding editor, why do you think one is, I don't know, superior? Did you try Genie for competitive programming? Do I have some example? I see some old comment from Sakin, 7, 10, 9, 1, blah, blah, blah. Is this a counterexample? If a proof is too long, then it's left as an exercise for you. You will learn something by proving stuff that I don't know how to prove. That's right. I tried dual booting, answering some old comments. I used double booting. Is it how it's called? Dual booting. That's how it's called. I tried dual booting in the past, but virtual machine is more convenient. Why 3 turns? Because I have a lemma that it only can get this complicated. That is, initially we have zeros, and I claim that there will then it's a correct strategy to consider some intervals with length being multiple of 3 to turn into ones. Then in that there will be some holes with zeros, and in that there will be some holes in ones. First I have DP computed for that, then for this, that. Right, let's print some debug information. At turn 1, there are some zeros. Turn 2, there are some positive values, and then zeros again. But this DP should consider the previous layer. New DP. For every interval from L to R, sum will be sum of values from L to R. If interval is long enough, including everything from 0 to n minus 1, new DP is a maximum of everything up to the second last element and something. Oh, this is something bad. What is happening? This line is not finished. Oh, it is else. Free? Nope. Two samples out of 3. Well, one sample is quite bad. Here I get 3 instead of 6. We change everything to zeros, and then we make some hole with ones. It will be easier for me to read this maybe if this is that. Should be enough, right? Yeah, should be. In the first layer is zeros with ones. Zeros with ones, right? Yep. What should happen there? Everything is zeros for me. I change everything to ones, then this is zeros. From 1 to 3, I should have ones without gaps. This is 0. Zeros will get ones everywhere. Those O's are actually ones. Then in ones I have a gap with zeros. All right. Well, here we have a lot of zeros, and that's correct. We'll take that. And here from 1 to 3, this is 0. I don't think it should be 0. Shouldn't this be... Oh, but it is. It is... No. -3. I'm confused by my stages. Ones. Zeros. I want to have ones from 0 to 5 with a gap. A gap will be from 1 to 3. So after the first stage I take this, after the second stage I take this from 0 to 5. From 0 to 5 I get indeed 6. Oh, so I wasn't okay. I wasn't correct to just say that we consider this last red interval of size 3. That's not how it works. When I said this, no, I tried to have quadratic complexity, but we need cubic. When I say that this white interval, it should have some red holes, I need to, I think, iterate over the size of the last red hole. Maybe it's this. And then I will take value from here plus this red guy. All right. Is this always correct? Can I always put sum? Isn't it only if it's divisible by 3? Oh. So independent thing is that this might have been incorrect. That's to do for later, but now iterate over size of that red thing at the end. And we have new dp from L to r minus size plus the red thing from there. That's dp from r minus size plus 1 to r. This is a red thing, and this is the rest. It was blue on the drawing. So we need ifs. New dp of lr. Maximize with that. Is it allowed? Yeah, that's r minus size is smaller than L, then 0, otherwise tag it, because it would be segmentation fault. Interval from 5 to 4 I treat as an empty interval, and it has a score of 0. What about you? Oh, we go with multiples of 3, so that's non-empty. Yeah, that should be good. But here I had something like that. Why? Oh, because I consider not taking the last element. So what about using new dp? I took this. I'm not sure about correctness. It doesn't work if L is equal R. I can put it here. But maybe if length of something isn't multiple of 3, I shouldn't allow that. I passed sample test, but I'm a bit worried. Is it fine to say that red hole is of length 4? Time complexity is n cubic. Don't you fear time limit exceeded? Not really. It's n cubic divided by 6, or maybe even 18. When you iterate over, okay, but multiplied by 3. So the actual number of operations, the number of times this line is run will be n cubic divided by a few. I think divided by 6. So that's fast enough for 500. Fast n cubic for 500 is okay, because it's 100 million operations. So it should take around 1 second. Unless, if time limit isn't very tight, then it's fine. Yeah. It should be fine. I don't do here any heavy operation. Oh, let's submit, or also bigger infinity for safety. If I get wrong answer, I will take care of multiples of 3. During a contest, maybe I would think a bit more to avoid penalty for wrong submission. Alright, it's quite wrong. Everything other than the last stage, I think, cannot have length being not multiple of 3. If this is not divisible by 3, alright, let's try again. That being said, here I use, okay, that is not, it shouldn't change anything, because here I take previous DP only with lengths being multiples of 3. I don't use DP, previous DP stage, in any other way than here. Alright, this should be the same. I think for every test it will give exactly the same answer, right? I hope that my lemma is correct. If not, and it happened to me in the past that I was solving Atcoder problem for an hour and then it turned out that my first idea was just completely wrong and I wasted time. Is this good? I said that in the first stage it's enough for me to take 3 last. I still think so. Or maybe not. Maybe not for the same reason as here I needed to improve that. Can't I simulate that by saying that previous holes are just empty or very bad? If I do this, just for simplicity, instead of here now taking care of intervals with length being multiple of 3, if I do this, Does it work? Then my code is a bit simpler. Submit again. This IDE is Genie. Right, nothing new. Time for brute force. Literally nothing changed. I will implement a brute force, the n factorial one. Or, well, it isn't much harder to do BFS. This is string with all falses. And now what do I... It can be DFS. It will try all the possibilities. Then consider flipping it all. S2 is S, S2 of... Okay, for each of them. And if not visited, DFS of S2. All right. Zero can always be done, yeah, because we can just ignore everything and not do any action. For every state, possible answer is this is exponential brute force, complexity is 2 to nth power. I have some kind of generator here. I do, cool. I will generate tests with random costs from -10 to 10, and n is always up to 6 for now. If all tests will be correct, then I will increase this value for n. When I run this generator, it will create different tests for different seed from the argument. Yeah. I need a bash script for that. I have one pre-written. I don't want all this debug information on the screen. Will we switch to Windows subsystem for Linux once support for graphic apps is out? Maybe. But that wasn't the only issue in using it. Do you ever write a brute force during contest to check correctness? Yes, I do. It happens. I have some screencasts on my YouTube channel, and you will see there that I do that during a contest. It's mainly to find a counter test because it's then easier to understand stuff. It seems to work for n up to 8. Basically, it's important for every mask of which value is positive and which is negative. It's important if my program correctly understands if I can get this mask. So for any n, I think that 2 to nth test should be enough. Can I upload this on YouTube? This is going on YouTube. Always you can see this link, and I'm double streaming. And then you can rewatch it too. I hope that my brute force is correct. If I submit it, I expect to see time limit exceeded only, or let's make judging fast. Assert n up to 20. Permission denied is because I recompiled. That's strange. Oh, counter test found very quickly. For n up to 10, it seems that everything is all right. Then if I do it for up to 12, then no. That's a counter test. Can I have one for up to 11? Nope. Right. This is counter test to my solution. Can I make it a bit nicer? 20, 40, 20, 50, 50. I'm just rounding values to something nice. Okay, the answer is now different by 10. Can I just change everything to equal values? Seems so. No. Right. The maximum I would get here is 120, 160, 200, 240. Well, that's impossible. Brute force says that 190 is max. So I can get 5 40s and 1 minus 10. This one. Yeah. Brute force finds something including this value, but I think excluding that. Can I modify every negative value to something even smaller? Yeah. I'm now very worried that the lemma is incorrect. The lemma about this being just zeros, then ones, zeros, ones, and that's it. I want to understand which values are taken. If I change those to 41s, will all of them be taken? Yes. Now, if I change this to 41, this to 41, no. Answer increased by 1, not by 2. Now, yes. No, no. This value isn't taken. I can change it to 39 and the answer will not change. What happened? Oh, yeah. So the current brute force takes those 120, 160, 200 minus 10, I believe. And my main program doesn't understand how to achieve that. Well, let's indeed think how to do it. It seems that we need to take everything and then make gaps. And the holes. This will be one big hole. Length is multiple of 10 indeed. Alright, so the first stage is to change everything into ones. To flip everything. Then we should do this. Change those back to zeros. Then I believe that 6 consecutive elements, those, and then make a gap here with zeros. And that's bad, because I thought that we will have 3 stages at most. This will be fixed if I have one more stage. It is fixed. I can submit it even with 6 stages. Maybe some more complicated lemma is correct, but now I'm doubtful in my solution. The question basically becomes, is it true that I do something with ones, then inside with zeros, ones, zeros, and this stops at some point? Or can we have a big pyramid of length n? The number of accepted submissions, accepted tests changed. Oh, I messed up the second example. What did I do? I think the parity must be good. Please give me accepted now. If my understanding is correct, then at least I have here n to 4th power solution. I believe if I change this to value bigger than n, then it's good. Do I at least have more accepted tests? No, it didn't change. If I do this, will it work? This will get time limit exceeded on big tests. But is the issue just that I use too few turns or stages? Or is it something else? Or maybe just all their tests are big. Will there be another stream where we can recommend you some problems? Yes, but not on Tuesday. Every Tuesday I'm solving hard problems from Atcoder. So that's really taking suggestions would happen just once every hour, because I take, let's say, an hour to solve a single problem. I prefer to just go through problems from one recent grant contest. But yeah, every Thursday I actually take suggestions from the chat. Thursday stream is very interactive, where I do coding interviews. And I wanted to experiment with Saturdays. That's easy competitive programming stream. In the past, I took always suggestions from the chat. Sideip, stop spamming. You already wrote the same comment. Are you sure that it's that important and relevant for the stream? The fact that you will do something and you will message me one day? Come on. Right, the tests are big. I want to know if this ever fails if I increase n. I should have added something like assert n is up to 200. If this is correct, then I would need to improve this DP to be quadratic instead of cubic. What about... I don't know how. What now, chat? Any ideas? I will try one more thing. Kind of, I don't know, 17. Maybe that's fast enough and will pass more tests. I'm just experimenting a little bit. Oh. At least it's being judged faster. And I'm stuck. I don't know what to do. It passed one more test, so it helped in some way. I can make it 3 times faster by doing this part only if r minus l plus 1 is divisible by 3. What else can I do? Do I really need this? Can I just do something for every interval? Maybe I should aim for something like dp of 2 LR. For every interval, it's just important if I'm now considering zeros or ones. I'm a god? Oh, I don't know. I think I would then solve these problems faster. All right, we'll aim for this. Where actually for interval, I don't care which exactly stage it is, just its parity. So we do mainly this. Right? Now, second is that I will iterate over the turn. It's 0 or 1. No, it's first true, then false. Actually, I mean, for each of them, I need to do something. I will try to compute dp of turn LR. And by default, it's this. Up to R minus 1. But also we have that. Where new dp just means this. New dp means this with R minus size. And this is dp of the other thing. Not turn XOR 1. Is that it? What do we print? I'm not sure. And when I'm not sure, I can either think or I can print both and see which one is correct. And this is now, oh, 500 by 500. I need to fill that with minus infinities. Why am I doing it here? I can just do this. Oh yeah, I actually don't need it because this happens. I assign. Anyway, I don't use the default value, do I? I think I don't. What's wrong? I don't use sum. That's suspicious. Please work, please work, please work, please work. Doesn't work. The answer for the first test is, I believe, 9. Remember how I told you at the beginning of the stream that it's nice if I solve ABC? Yeah, it's now 2 hours into the stream and I solved A. After looking at the tutorial, that's important too. For now, I would solve during a contest 0 problems. Minus, talking about stuff, but that's a detail. That's a detail. It's 9 here. This is my DP of a bit shorter one. And this is the last red thing. Zero, or take this, and the other type of DP. And this is for shorter interval. So shorter intervals need to already be covered. L and smaller r. I think that's just about the order of L and R. From shortest to longest. Okay, second value is always good. So submit. Oh, well, not submit, I can just test it. But I prefer to test for smaller n's, because then it's more likely that something interesting will happen. Okay, compiled. $2,000 random tests passed. right? I think I did it in 1 hour. But I didn't look at editorial. I solved problem B. Those Atcoder problems are so hard. What does the tutorial say? Let's check if it's possible to reach a state where these case cells contain coins and no other cell contains them. We start with an empty string. Are we allowed to insert strings? What? Okay, they look at values modulo 3, then they change every position into its value modulo 3. Hmm. Well, that's different than my solution. They rephrase the problem as looking at not just the binary string, but looking at a sequence of values 0, 1, and 2, the remainders modulo 3. Then any sequence of ones, it can be achieved only if it's enough to look at if the sequence of ones is at positions 4, 6, 7, and 10, then it's enough to look at remainders modulo 3, so 1, 0, 1, and 1. And let's say the next one would be 11, then this would be 2. So this sequence, and we try to achieve it, and they prove how this is about starting from empty string and inserting 0, 1, 2, or this or that, or removing, and then they say that removing is redundant. They only insert, then if they have a long sequence that they want to get, they wonder what the last operation is. Let's say it creates those, then those shorter intervals, they need to be created. All right, and then just, that's dp of shorter interval. I didn't go that direction, but a lesson for me in the future is to more often think about values modulo 2 or 3. I remember in the past using things modulo 3 like this, some kind of then various lemmas can be derived this way. Fine. Let's try one more problem today. Problem C, block game. Close everything else. You can now access updated link in the chat. There is a string with characters B and S. Snook stands on one of the cells. The string says who moves when. If it's B, then it's your turn. You choose a cell that contains neither other blocks nor snook and put a block on that cell. Just block some empty cell. After that, if both of the two cells adjacent to snook cells are blocked, you win and the game ends. Wait. He cannot. Can't I always win? What's going on? How can he ever move forever? Snook wins for this? I didn't understand the problem. I thought that if he starts somewhere and then I block something in one direction from him, then he moves some. I will block something in the other direction, then he's in limited interval. The link command has some cooldown. If it doesn't work for you, you can try again in like 10 seconds. If it's your turn, you block some empty cell. Does this mean that I understand this as from x move to x plus 1 or x minus 1? What do I not understand? Like, imagine this infinite thing. Snook starts here. He moves for some time. Whenever it's my turn, let's say I block a cell next to him to the left. Then he moves, and let's say after he moves a little bit, he's here. I will block this, and then always he moves for some time, but I will then shrink the interval where he can move. So I claim that if I move at least once, then I win. You only have t turns to achieve it? Oh, the question is how quickly can this happen? Thank you. Thank you, the Flying Dutchman. The question is how many ways there are to replace question marks with who moves, so that, what is t? Oh, I see. It's just that the string is not repeated. I thought that this string goes forever. Like here we move BS as BS, then again BS as BS, and so on forever. But actually it's not written anywhere. He needs to survive those turns. What happens there? He stands somewhere. He stands somewhere, then I block a cell next to him. Next to him sounds optimal. Just it's a decision whether on the left or on the right. Then he moves. He will here move as far away as possible. And he moves twice, so he will be there. Then I block him again. I always, after I block him, always he will be next to my block, and then it just, the only thing important for the state is how long this interval is. And if this is the situation, and the length of interval is say 10, and now he needs to make 3 moves, then he will move all the time to the right. But if he has like 70 moves, he will stop at the middle of that. I believe that new interval length will be minimum of the number of his moves and Alt L over 2. Plus minus 1. And will be up to million. I believe that this already gives us polynomial solution. It will be just hard to do it in linear time. After he moves here, I will block him like that. So yeah, I believe this. Let's think about details. If this is the case, so there are 6 cells here, then he perfectly wants to move there. I will block like that, and he will have 3 cells. So from 6, perfectly I will get down to 3. If he cannot move at all, then we move to 1. Maybe we should talk about the number of empty cells in the interval. From 5, if he moves here, then we will cut him down to 2. Unless he doesn't have enough moves. Like if he has 0 moves, then this. Alright, so new empty is mean of moves and empty over 2. I think that's the formula. Empty means how many empty cells there are not taken by Snook and my blocks in the interval where he can move. Does it work if the number of empty things is even instead of odd? In here he will move there. Number of empty will become 2. All right, yeah. This is the formula. This thing. Whenever empty becomes 0, I win. If he moves initially, any first moves like S, they don't matter. Just when I have the first block, if this is the situation, if this is the string, some S's, then B, then some S's, then B, then this is how far he moved away. Empty is exactly, this is exactly the initial empty. If he moved once, and then I block him from the right, then he created for himself 1 empty cell. And then the real game happens on the right. I mean, in the suffix of the string, starting from this empty. Right, then one cubic solution will be for every position, if it's B, then dp of position I, assuming that it's B, and the number of empty cells, number of ways to fill characters s of 0 up to I, so that s of I is equal to B, and this given particular number of empty cells, this thing. From that we can move to any future j. From that we will iterate to j being the next b. And that can be done with some prefix sums maybe. This is the transition. From I to j, moves is how many s's there were in between. From dp of 10 and let's say 50 and 10 empty, we'll move to dp of 52, and then to 52 there was 1 s in between, so just one move. So then it would be 1. 50 and 10 to dp of 53 and 2. So generally to dp of 50 plus 1 plus x comma x. But eventually this is limited by a half of empty. This is still 4. 6 is 5, and then always a 5. So this is easy with prefix sums, and this is easy with prefix sums, where maybe, well, this is kind of diagonal prefix sums, if you imagine this, the two-dimensional DP array. All right, so n cubic is trivial, and easy-ish n square with prefix sums. Then the difficulty will be to do it faster. There will be at most logarithmic number of B operations. Maybe that helps. In particular, if in the input there are more than 20 Bs, then I can cut them. Your drawing tool is crying? Why? What happened? Is it some sound or what? Some problems are better shown with just, something like that. I'm not going to type all those characters. I think everything here is clear, what happens exactly. And this is for sure easier to be done in even Notepad. Okay, if there are more than 20 Bs in the input, then I can cut those. Oh no, then B always wins. We don't need to say when exactly the game ends, just if it ends. There can be at most 20 Bs in the string, otherwise empty would reach 0. Right? If there's like, we go from B to B and there's something, then B, then S's, and there are like, let's say 12 of them, then it means it actually is some kind of limit for the future number of Bs, because we know how many times we can have it. From 12 there will be 6, then 3, then 1, then 0. So logarithm of then, there can be log of 12 more Bs on the right. I would say that this gives us better DP. This will be DP of I and remaining Bs or something. So ways so that S of I, ways to fill everything up to position I, so that S of I is B, and there can be X more Bs on the right. It doesn't matter if this value is 10 or 11, I claim. Because it's important just what happens after taking half of it. Oh, that's nice. Now I feel excited that maybe we're moving in correct direction and we will get this problem. Also, we can move from the right, and we can have dp of ix will then be the number of ways to do something in suffix, so that here we would have b, and we had that many b's so far. If we had 3 b's, or if we had like 10 b's, then now we can have a gap of at most 1024 s's. It seems better to move from the right. Yeah. Ways to fill suffix so that s of I is b, and there were x is. If there are two more b's and I have a b here, b as b as b, and I'm looking at this position, then how many s's can I have here? Let's remove a word more, xb's on the right, including this position. This is dp of I 3. This means 3 times halving it. If this is here is 4, then it will be decreased down to 2, then 1, then 0. That's bad. Also, there can be s's there. If this is 7, that it's bad as well. This must be at least 8, because then it will be divided by 2, it will be 4, then 2, then 1, still good. If this means that we need at least 8 s's now. At least 8 in a row, and then we can have another b. If there is some b here in the input, then that's bad. If those are all question marks or s's, then I say, well, they need to be turned into s's. And then starting from that 8th position from this forward, we can say, well, any of you can be the first b. And that should be trivial and square times log, but log of n will be possible as well quite easily. But I will first do this with n square solution, just to get correct answer here. Or maybe even exponential. How many question marks are there? How to easily check that? I will just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18, 20, 24. All right. This, I can check my lemma or lemmas with just a brute force that would change all of those into b's or s's. And then I would check if I have a correct understanding of this. 24, yeah, thank you. I got the same value, so we are correct. How to easily check that with some kind of, with something in bash? There's still stress testing going. This counts tokens, characters, and lines, but I don't know. Bash, how to count characters, not in a string, particular characters. All right. You can combine translate or delete characters with this. See. So remove everything here. I'm just learning bash now. It's not related to a problem. Pass this to trim everything different than a question mark. And okay, yeah, now I got just question marks from this, and WC will count them. Cool. So it's trim and minus CD. C complements, D deletes. Nice. All right. I don't know if I will remember that. And there's also grep, but I never remember how to use it. I always Google it. I hoped for some other simple approach. Both seem fine. All right. Let's try the quadratic one. So let's try this thing. And then we'll move to that with some kind of prefix sums. Shouldn't be hard. Should I reverse the string? Maybe, maybe not. When I'm in file s.sh. Did you do advent of code? I didn't, because mainly because I'm quite competitive, so I would want to be at the top of the leaderboard. And for me, every round started at 5 a.m. or some other terrible time, middle of the night. I won't wake up like this for a month. No way. We read the string. What now? It's dp of nax and 20. Like that, or 21 goes second? Let's move it. Let's do it like this. Do I want to reverse? Yeah, I want to reverse. So then it becomes harder to debug. Let's not reverse. And there's some modulo. But modulo will not be useful here. So for now, let's do stuff without modulo for convenience. I will then add it at the end. If s of I is b, then break. But otherwise, dp of 1i. I want to say that you are the first b. If you're not hard fixed s, then you can be b. And we say dp of 0, not 1i is 1. And also if it's b, then break, because you cannot have the first b on the left. Now we have some first b. And we move from the right. Actually, that doesn't matter. We will move to future dps. Right. There are that many ways to get to position I, to say that b is here, and there were that many b's so far. And now I'm allowed to have at most that many s's. Like if there was one b, then I can have two s's. I need at least. Like if there was one b, then I need at least two. Otherwise, something would become 0. I count the number of ways so that Snook would win. He will, because the gap will not shrink down to 0. I need to count ways such that I will win. At the end, print always minus dp of something, I don't know. Don't know what to put here. the S's at the very left, S's on the left in the prefix, they don't matter. Any B can be first, assuming that there are no more B's on the left. So yeah, I will use that. I need to here say, if no B on the left, then answer plus equal me. This will be easier if I do it in the other direction. And in B. Shouldn't then continue, damn it. S of I is B. Oh, I should have. Okay, there's easier way for that doesn't rely on the order of operations. I will find position of the leftmost B. That's easy. Right, if no B on the left, so if first B greater equal I. And I can be B. Okay, but that's satisfied here. Right, can it happen that nothing is B? I think so. This is if nothing is turned into B's, just everything is S's, otherwise there will be some B. Okay, and what do? I say that at least that many S's there must be from here to the left. I minus 1. If j is smaller than 0, or this is a B, then that's bad. I'm solving this problem from Atcoder. You can grab link from the chat or even Google the title on Atcoder. Can you give me some tips to become good at DP? Sure. Solve problems for marked as dynamic programming. That's it. I made some lectures. You can watch them. But there's nothing like tips for competitive programming other than the fact that you learn stuff and then you understand that. Like here, I'm doing dynamic programming right now. So a tip is do what I'm doing. Don't forget the answer is mod some big number. Sure, I usually do that at the end because it's convenient for me to... It's faster to write this way without caring about all of that, though it's dangerous. The best method is to have a struct for that. Please solve P versus NP, stop solving useless problems. Sure. I mean, and what now? Now, sports are not allowed. You will say to everybody doing sports that they should start flying instead of running, because that's useless. If bad, continue. And now, after that many S's, you can do stuff. This, consider this to be the next B. If you're not hard-coded S, then it can be the next B. dp of layer plus 1 j plus equal. Also, if b then break. This is very similar to that, to this thing, so I guess I should have resolved that with something like dp of 0 n is 1. Yeah. What do you want? At least s. Let's see. Oh, almost there. I'm wrong by 15. What now? I can iterate over possible strings that we can get from that and try each of them. No, that doesn't make sense. I would need a brute force. I allowed too many strings, so but that's after subtracting. So here I find too few strings. Answer. All right. This should be increased by me multiplied by the number of question marks on the left. Like this is the first B. Same here. Should be multiplied by the number of question marks. Am I right? Oh no, because this means everything turns into S. And this also means everything on the left turns into S. So nope. That wasn't it. Right, let's cheat. I'm assuming that I can do, or should I just implement a brute force? I can, okay, chat, quick poll. You can type 1 or 2. 1 is implement brute force, which will be boring, but you know, something. And 2, take solution from somebody else. And I will not read it. I will pretend that I implemented the brute force. This will take like 5 minutes, 1 or 2. And after I do that, I can even, I guess I will experiment with this. I will change some question marks into real characters, or just I will try to decrease this test to find a smaller counter test and then analyze what's exactly wrong here. 1 1 1 2 2. For now, option 1 slightly wins. Hi, boneless beast. Also, this will be the last problem for today. Next stream will be on Thursday, but it will be very short because it's, how is it called? New Year's Eve in English. Yeah, I don't want to spend the whole day coding. I can also vote as a tiebreaker. Thank you for allowing me to do so. Implementation is just pain and there might be some bugs. I mean, you can tell that, you can say that about almost any problem. Implementation is generally less interesting than coming up with a solution. 1 1 1 2 2 2. It's a tie for now. So I get to decide. Cool. Not editorial. I wanted to do standings. Yeah, I'm voting for text solution first from somebody else. Just let's try not to look. Right? I don't actually need a script. He's on into, mine on into. Right? Well, first, is that still different? Yes, it is. Yes, it is. Still. Right, so we need that many. What? Did he say -1? If there is a single B, then how many times do we win? It's 0, right? Is that an incorrect solution? I don't think there is hacking in Atcoder, but well, I didn't expect that. Can somebody check in Codeforce's discussion if this was mentioned? All right, let's grab code from the second person. Copy. Maybe I'm doing something wrong. Not this. Yeah. Okay, he's just wrong. He prints. He gets answer of -1 on this test. Which modulo mod is that? Okay, weak tests. I don't claim that Unix shouldn't win. Actually, let's see if it was close. Well, it wasn't close. If he got wrong answer, it was just on a single test. Well, you wouldn't see that. He would waste some extra time. But he wasn't close to reaching 3 hours or whatever this competition was. Was it longer than that? 197? Was it 3 hours and a half, I think. So he would win anyway, but still. All right, then maybe it's safer to work with dualities code. Okay, this is different. This is same. Same. Different. Same. Different. All right. My solution doesn't work for BSB, where I block, he moves, I block. Indeed, if he moves once, this is okay for him. That's because the very first, and then here what's allowed? SSB. If two S's, if he moves twice, then block, he moves once, block, yeah, he still survives. So it's that just power decreased by 1? All right, that was just... Then it's a very weak test in some way. If I took a wrong power and I had almost a correct solution. All right, we have a quadratic solution which is correct, I hope. We can make it longer. Okay. Overflow, too many question marks. Right. I didn't change much. Let's use 35 characters and then some random changes. Right, fine. This was just, modulo. I believe it would be this. Now, time to make it faster. This is checking if in some interval there is B. Easy. What is that? This is to some interval adding me. Interval to some interval adding B if your question mark or B. All right. Basically, any DP cannot be considered if you're exactly S. So what about, I change this a little bit. If S of I is equal S, then continue. And then we can remove this. And answer is still correct. So starting from this position to the left, find the first B, or just position 0. And you can add to this interval. Fine, let's do that. From every position, I need to know the previous B. Previous B. Can it be 0? Actually, from 1. If S of I is B, then this is the previous B. Right, done. From here. Once I change this to this easier format, where just I see that we operate in some interval, it will be easier to do prefix sums on that. And can find R already here and say R smaller than 0, continue. Cool. This is good. I mean, maybe this is not the strongest test because there aren't a lot of B's. It's fine. This checks if there is any B here. previous b of I minus 1 smaller than I minus at least. Right, because we check up to that. Cool. Is that now the only quadratic part? Somebody wanted a tip for dynamic programming. So this is how I solve it. I do something in worse complexity, then I simplify the slow part, the bottleneck, so that here I see that this is dp where I just add to some interval, and then I can just do, what can I do? dp of layer plus 1, r plus 1 minus equal me. Now if I do prefix sums on this, I will be good. This is how you add to interval in constant time. Here and I. Those two things combined will work. Also for layer equal to 1, we don't do that because we have this. Nope, I messed up. Maybe somewhere else we also touch dp. This is prefix sums on positions, not on layers. So it's correct, all done, just need to use model. I prefer if statements allow you to copy paste this value instead of putting those things for clarity. It's not that I really need to see what is this number exactly, other than to copy paste it to the to code. I guess add self will be the most common function. Maybe not, we'll see. What else? What else? Sub-self will subtract one number from the other. Again, modulo the given mod. And done after I make this function. What do you want? I missed something. Oh, actually, I can just see 42 and 36. That doesn't tell me a lot. Oh, the power, right? This. Nope, not that. Is the problem written somewhere? I just joined. Yeah, you can always use this command, almost always. !link in Twitch. Like the title, by the way, suggests. And the link is not up to date. Why? It should say. I didn't hit save. All right. But this was just the last character. Now it works. I'm finishing this Atcoder problem, block game. All right, I didn't comment out this line. Now should be good. I'm just checking the speed. 100,000. Okay, this is enough. 160,000. That's very fast. Duality's solution is slightly slower, but whatever. The goal is to be below the time limit, not to be the fastest. Did you enjoy today's problems? I'm embarrassed about problem A. This problem C was fine, it was just easier than the other two. I didn't like 3 coins too much because Atcoder just uses too many of those problems where you need to analyze some kind of sequence. I'm very happy that I came up with a solution, and for B and C I didn't use editorial, and that's good for me. I often during those upsolving streams I need to look at the editorial. This is what happened for A. I didn't solve A. I looked at the editorial. B and C were fine. But still, like with ABC, it's not that I would have a good score. People in the top solved ABC in hour and a half. I now spent 3 hours and I didn't really solve A. Somebody said that tourist didn't solve A. Is that tourist? No, this is not that tourist. Is he here? Is there... Oh. So he didn't do that well. He got 62nd place. He didn't solve A. That happens. So I'm not worse. That's something. Well, of course, I'm slower here, but it doesn't matter too much. Everybody struggles from time to time. What place did you get? I didn't get any place because I didn't participate. You can see with this time of solving B and C what place I would get, but not good. Though I would be faster because I wouldn't talk with the stream and I would try D. I don't know if I would solve D in the remaining time. The contest was 3 hours and a half. But I wouldn't be top 20, that's for sure. Just I wasn't very fast. No, I was fast enough on C. That's something at least. All right. Thank you everybody for watching. Check out the Discord server, my streaming schedule, and see you in 2 days on Thursday when I will do coding interviews. Am I good with greedy algorithms? Not better than others. Not that I would say that greedy algorithms are my area of expertise. I'm quite good at DP. Yes. Though some Atcoder problems are just very hard dynamic programming. So it's still more about observations than about DP techniques. I solve medium DP problems very fast, but not greedy. All right. Thanks again for watching, and see you on Thursday. Bye-bye. Unless somebody's streaming and here on Code Versus, no.